Okay, can you see this?
Yes, sir.
Okay, so this is what we have seen this one. Now, once you know this one, other things will be easy. Another similar Oxycode rearrangement. So Oxycode rearrangement is that the cope is co-rearrangement is 1,5-diene. In that case, if you have OH group or OR group substituted in C3 or C4 in 1,5 rearrangement, known as Oxycode rearrangement. So we have some example of this one. Let us see this. Sorry, this is going to be. Let me put my pen on this one. So this example, let us see. So this is 1,5-diene. This 3,3 Sigmatropic shape. Now you see, once you do know the theory, application part you can do it mechanically. Mechanically you can, but theory is must. You must know what is the theory behind this transformation. Because once without understanding theory, mechanically getting the answer and all these things you can do it mechanically. So you can quickly see what is the bond breaking. This is 1, 1, 2, 3. This is 2, 3. So this is going to be 3 Sigmatropic shape. It is going to take this normally. And this is just see this OH group is there. Once this OH group is there and the diene, so it becomes an enol will be transformed. So that is very simple. And the equilibrium will be shifting this side. If it is O minus, suppose it is O minus, this becomes a faster reaction. So it takes this at a lower temperature and we get this O minus. But once we hydrolyze this one with OH, with acid, this becomes OH and it will become, again, we'll get the same product. So here we have another example of this nature. This is going to be the product that we have here. So this is your Oxycode rearrangement. Let us find another Azacode rearrangement. Aza means what? When we say Aza means, it is what?
Nitrogen is.
It is nitrogen. So when it is nitrogen, you see here what it is going to be. This instead of one carbon here, you will be having a nitrogen. I think only 21 people still know. Achha. So here nitrogen, but this is the product, nothing different. Now here this diene system is prepared like this from this compound. It's prepared first. Once we prepare, we have this this fossil is here. So there will be elimination of this and we get this diene. Once we get this diene, finally it will get converted to this. So this is nothing very special. Coming to now, we have done cope rearrangement. Now this is Claisen rearrangement. Now Claisen rearrangement is the one of the earliest Sigmatropic shift that was studied extensively. And what it is, this is nothing but in 1,5-diene, you have got one of the carbon atom at 3 or 4 position will be shifted, will be replaced by oxygen. So that is your. So it becomes ether. So it becomes an ether. What is that ether? This part is allyl group, and this part is vinyl group. So it is allyl vinyl ether rearranged to gamma delta unsaturated carbonyl compound through C3 Sigmatropic shift. Is Claisen rearrangement. This is equivalent to your cope rearrangement with the heteroatom oxygen in 3 or 4 position of 1,5-diene. So that is what. And what it is going to be the 1,3 Sigmatropic shift because this is the bond which is breaking. So it is 1, 1, then 2, 3. Here it becomes 2, 3. So this becomes your 1, 3 Sigmatropic shift. And we get this product. And let us come to these examples. Like cope rearrangement, rearrangement reaction passes through this 6 member. So that chair conformation that we get here, get in earlier case, here also it will pass through that 6-member transition state. See, except that oxygen, one carbon is replaced by oxygen. chair conformation of cyclohexene transition state. That is a very important point. Let us see this one here. So it is shown here. So this is the transition state that happens, and we get the product like this. Okay. So no problem. Let us not waste time here. You see, and this is another phenyl allyl ether. Already we have done this example earlier. This is a 3,3 sigmatropic shift. Here aromatization happens, so we get orthoallyl phenol. Orthoallyl phenol. Okay, so this is also, and we have seen also this earlier example. Now here, the same way that we have done earlier, the stereochemistry of this. This is going to be EE conformation configuration. The product when it is, we get when this when it is EE, we get this as the product. Means we get the sorry, this is NP. The 2-methyl group here will be in NP conformation. And this one also will give, if it is ZZ, this is ZZ, will give you this product, but it is going to take place at a higher temperature. And in this case, this is what? This is E and Z. We get this syn product, the syn product, and take place at a lower temperature. This temperature and this temperature are more or less equal. And this is also 3,3 sigmatropic shift. Now here, this temperature is little difference because this the position of the oxygen which is there, and in this case, the vinyl which is there in the E conformation and allyl is in Z. But here it is vinyl is in Z conformation and allyl is in E conformation, E configuration. Sorry, conformation. So that takes a little higher. Now this transition state. So here you can get this using the same transition state theory. Just okay. So you can arrange them and get this product. And I have not given this one. It is up to you. Not up to you. You should do it and find out that this in this particular conformation you are getting. Okay. This is another example. Now what it is? This is going to be. So what is this one? This is nothing but your acetal. Acetal is equivalent to your keto group. Keto group or aldehyde group. Rather, it is keto. With oxygen is going to have a reaction with this, and we get this. Once we get this product, we get this. So this is the basic chemistry here. One simple chemistry, and then we get this. So this is also not very difficult. Now let us quickly come to this one. This is a very, very important thing. I'm going to give you two questions after this. You will try to solve it. Let us finish it. 2,3 sigmatropic shift. The earlier one was 3,3 sigmatropic shift. Here, 2,3 sigmatropic shift is allyl variant of 1,2 sigmatropic shift. 1,2 sigmatropic shift we have not taken here. All those rearrangement like Wagner-Melvin rearrangement and other things that we have got in say first semester or second semester, or also you have studied in BSc. They are all 1,2 sigmatropic shift. Of sulfonium or ammonium elites of alpha metallated ether, general representation made as B. Now here, let us take the system without going much through this one. Let us take the system. What it is going to be. So this is an allyl. Some of you are talking. Some of you are talking. I find here only 20 of you. So this is the allyl system you find here, and will be connected to a heteroatom, nitrogen, mostly nitrogen or sulfur, nitrogen sulfur mostly, heteroatom, and another atom which may be also carbon, usually heteroatom, with a pair of electrons. Now, carbon with a pair of electrons can come in different forms, like carbene is here with a pair of electrons. C minus will be here. Oxygen and sulfur also, nitrogen will have their own lone pair of electrons. Now, basically what it is, this is a pair of electron and this heteroatom, this part will form an elite. So there will be an elite formation, and this elite formation then undergo a shift like this one, where the breaking of this particular bond, 1, 1, then 1, 2 here, 1, 2, 3. So there is going to be a shift like this, which is your 2, 3 sigmatropic shift. 2, 3 sigmatropic shift. Let us see some examples then. The reaction occurs superficially through allyl unit via pipe-membered envelope-shaped transition state. So we have a transition state like this, which is there. Okay. Involving this geometry, we'll have some other discussion later on. Let us see. This is a reaction which is mentioned also in your syllabus, Somlet-Hauser rearrangement. Somlet-Hauser rearrangement. What it is? Benzyl ammonium iodide. This is your benzyl group. Ammonium, this is your ammonium salt, the trimethyl ammonium. Benzyl trimethyl ammonium iodide. So this is salt. When you heat this one with NaNH2, which is a strong base, NH2 is a strong base, it rearranges to 2-methyl, this is 1, 2, this is 2-methyl, N-dimethyl benzylamine. This is your N-dimethyl benzylamine. N-dimethyl benzylamine. So this rearrangement is, and why we are studying this one? This rearrangement takes place with the formation of elite. This elite is formed and subsequent 2-3 sigmatropic rearrangement. So there is a 2-3 sigmatropic rearrangement that is happening, and that has happened here. So let us see its mechanism. You see here, this is your benzyl ammonium iodide. Now this, because of this electron withdrawing group of this one, this hydrogen becomes acidic. Once it is acidic, NH2 group can pick up this proton and become C minus. Now once it is minus, so this becomes an elite. Heteroatom with carbon negative here, positive and negative. So that forms, there is some stabilization of this one. And so this is benzylic elite. You get an elite. This elite, because this is proton, this proton can pick up another proton from this methyl group. Sorry, this negative charge, this anion can pick up this one proton from here, and we get this carbon ion from here. So we get, this becomes another elite. So it is a second elite that we get. This second elite, you find here, there is stabilization. This elite then undergoes what is called 2-3 sigmatropic shift. So we are having this one heteroatom. This is heteroatom, and there is another atom. So this is Y, and this is Z atom, and is going to have this sigmatropic shift. What is that? This is 1, 1, and then 2, 1, 2, 3. So this is 2, 3 sigmatropic shift after this. Once it forms here, then aromatization of this one will give this. I think that is simple after that. This is Somlet-Hauser rearrangement. Another 2-3 Wittig rearrangement. Wittig rearrangement you have studied in your second semester. Wittig rearrangement. So there is 2 types of Wittig rearrangement. One is your 1-2 Wittig rearrangement. Another is 2-3 Wittig rearrangement. So here, what we find, transformation of allyl ether into a homoallylic alcohol in presence of strong base like butyl lithium at low temperature is 2,3-Wittig rearrangement. The reaction takes place through concerted mechanism, is a pericyclic reaction, 2,3 sigmatropic shift. If the temperature is raised, the chance of 1,2 rearrangement increases. So this is the what we find here. This is allyl, and this homoallylic alcohol in this. Now this butyl lithium, what it is going to do? Butyl lithium will pick up a proton from here. Okay, mechanism we'll see this one. We get, first of all, we get this one, then hydrolysis of this, we get this alcohol, homoallylic alcohol. Now, what is the mechanism? Mechanism is this. So this butyl lithium will pick up a proton from this one. This is an acidic hydrogen. So this C minus, oxygen is there, that is the heteroatom. So this system is there. Just see, this system is there, and we get this. So the 1, 2, 2, 3 sigmatropic shift, we get this. And hydrolysis of this one is going to give us this. So hydrolysis of this is going to give us this. So this is your 2, 3 sigmatropic shift. But this is not the thing that we have. The application of this one is more important. All right. So I'll forward to problems immediately. So you come back to your room. I'll forward to problems. You try to solve it. And there will be involvement of 2, 3 sigmatropic shift in both cases. But it will not be a one-step process. There are other reactions as well. Because when you see in your NET examination and all, you don't get a direct question. A one-step question, it is hardly in organic chemistry it is given. So 2, 3 reactions are combined together and we get this. And in this problem that I will be forwarding to you, 2, 3 sigmatropic shift is here in one of these steps. So try to solve that one, and we'll solve it once you submit your answer. Okay, and that was also to NET questions set in some years. I have forgotten, so I picked up from here. And then let us see. Okay, I end this to here. I discard this and then stop this sharing. I find here 21 people. Okay, you come back to department quickly. I end this over here. All right.